This recording is for 2 lessons on progressions. One of them is for sequences and the other one for series. So some key vocabulary words to watch out for: arithmetic sequence, geometric sequence, summation notation, what a sequence is, what a series is, finite sequences, and infinite sequences. So we're going to go through some sample problems to help you through these 2 lessons. The first one is write the first 5 terms of the sequence. And so the sequence is given by a sub n, which is n squared plus 2. So it's kind of like a little formula or a function that you're going to follow. So if I want the first 5 terms, then I'm going to plug in 1, 2, 3, 4, and 5 respectively into n. So if I do 1 squared plus 2 gives me 1 plus 2, which is 3. So that's the first term. Then I do this for each one. So 2 squared plus 2 means that I have 4 plus 2. So the second term is 6. 3 squared plus 2 means I have 9 plus 2, which is 11. 4 squared plus 2 is 16 plus 2, which is 18. That's the fourth term. And then 5 squared plus 2 is 25 plus 2, and so the fifth term is 27. So our first 5 terms are 3, 6, 11, 18, and 27. Next example, find the 18th term in the sequence. So they give us the first few terms of the sequence. So what we have to notice is this is an arithmetic sequence, so the same amount is being added each time to get to each number. So 5 plus 8, or 5 plus something equals 8, 8 plus something equals 11, and all those somethings are 3. So we're just adding 3 each time. And then we also have to focus in on that first term, which is 5. So if the first term is 3, 3 times 1 would give me 3. That's not 5. So then I have to look what is the remainder piece to it, and so that's adding 2. So we can see that that works for the second one too. If I have the second term 3 times 2, that gives me 6. If I add 2, then that gives me the 8. So to find the 18th term, that means we're going to do 3 times 18 and then plus 2. So 3 times 18 is 54. 54 plus 2 is 56. Geometric sequences are a little different because instead of having a set number that is added or subtracted to each term to get to the next term, it's something that is multiplied. So what times 4 gives me 16, what times 16 gives me 64, and so on. And so we see that this is a multiple of 4. So we could say that this particular sequence has a common ratio of 4. Indicate the general rule for the nth term. So we want a general rule. So we're going backwards. Instead of given the rule and finding the pieces, we want to find the actual rule. So our sequence is these terms here. And so we first look for a common difference, and we notice that we're subtracting 3a each time. And then we focus on that first term, but it's not enough to just say, oh, well, we're subtracting 3a, but how did I get 6a in the first place? If I subtracted 3a, what did I have? What was it? Something minus 3a gives me 6a. And so that would be 9a. So 9a minus 3a would give me 6a. However, we have to know that there has to be a multiplication there somewhere because of the term that we're talking about. Just like the one where we found the 18th term, we had to have the actual numbered term in there. So here this one works because it would be times 1, so we need to figure out where that goes. So let's focus in on the second term. If we multiplied the 9a by the number, and so this second term would be times 2, then we'd have 18a minus 3a. That would not give us 0. So then we have to think, well, maybe it's actually this one that's multiplied. And so let's take a look. So if we have 9a minus 3a times 2, then that would be 9a minus 6a. That would give us the 3a for the second term. Now let's see if it works for the third term. So we have 9a minus 3a times 3. That would be 9a minus 9a gives us 0. So that works. So our general rule, we can write it a couple different ways, would be 9a minus 3a sub n, or you could write it as 3a times 3 minus n. Either way. Summation notation kind of looks like a big E, but it means that we're adding up the terms. So in this case, we're going to start with where n equals 1, meaning our first term, up to the sixth term. So the top number is where we stop, and then they give us the rule that we're going to work with. So what this means is that I'm going to find all of these terms first by plugging in 1 for n and then 2 for n all the way up through 6. And so we have 1 over 2 times 1 plus 1. And then we have 2 over 2 times 2 plus 1. And then we have 3 over 2 times 3 plus 1, and so on. And figuring out what these answers are. So 2 times 1 is 2 plus 1 is 3. So the first term is going to be 1/3. Then the next term is 2 times 2 is 4 plus 1 is 5. So then we have 2/5. The third one is 3/7. Then we have 4/9. Then we have 5/11. And then we have 6/13. And because it's a summation means we want to add them. So 1/3 plus 2/5 plus 3/7 plus 4/9 plus 5/11 plus 6/13. And you actually want to add up all of those numbers and get the end result. So in this case, you get about 2.522. We can also go backwards, so they might say express in summation notation. So we know that we are going to have a summation symbol. We're going to start with n equals 1. We have 6 terms there, so we're going to go up to 6. And then we have to see how do we get from term to term. So 2 times what gives me 4? 2 times 1, we could see if it's just 2 times n. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. So our general rule would be 2n for this one, and we would get those terms. Alright, the last example we're going to do is a little bit of a long one, but that's why we're doing it here. So it says the sum of the first 3 terms is -7/10. And then it also says that the product of these 3 numbers is -1/125th. And it asks us to find the numbers, and it gives a hint, and it says use A over R, A, and AR as your digits you're trying to find. So we know that A over R plus A plus AR has to equal -7/10. And so first we want to write these so that we have them as one fraction. So that means that I want this to have something over R for each one. So this one's already there, but then I have to multiply by R to the second one, so I have AR on top, and the same thing for the last one, so I have AR squared equals -7/10. And then I can write that as A plus AR plus AR squared, all divided by R, equals -7/10. Now we don't like fractions very much anyway, so if I multiply everything by a -10 to get rid of this denominator, and I also multiply it by R to get rid of this denominator, then I will have -10a. I'm going to distribute that. Plus, actually not plus, minus 10AR minus 10AR squared equals -7, or not negative, +7R. Now the other thing is I can leave the 10 out, and I can also pull an A out of there to make it look a little nicer. So if I pull the -10A out of there factor-wise, then I have 1 plus R squared left over in there. Now we leave that alone for now because now we have to focus also on the product piece to this. So they said that A over R times A times AR equals -1/125. And so if I actually multiply these, I have the A times A times A gives us A cubed, R on the top, and an R on the bottom, but the R's cancel, so we're left with A cubed equals -1/125. Now to get rid of a cube, I can cube root it, both sides. And so we would get A is equal to -1/5. And now we can take this and plug it back in to that equation there. So now we have -10 times a -1/5 times 1 plus R squared equals 7R. And so -10 times a -1/5 becomes 2. times 1 plus r squared equals 7r, and then we can distribute the 2. So we have 2 plus 2r plus 2r squared equals 7r, and since that looks like a quadratic, then we want to solve it like a quadratic. So we have to subtract 7r from both sides, and we get 2 minus 5r plus 2r squared equals 0. Now we see if this will factor, and it does. We end up with 2r times r to get the 2r squared, and then we have 2 and 1, so we want them like this, and both subtraction. And then we set each one equal to 0 and solve. So here we get r equals 1/2, and here we get r equals 2. Now we want to plug those into our 3 pieces that it asked for, because it said our digits are a over r, a, and then ar. Now in this case you can plug in either one because they both work. So you could use 1/2 or 2 for that. But a was negative 1/5. And so a over r is negative 1/5 divided by 2. Flipping that becomes negative 1/5 times 1/2. That gives us negative 1/10. We know a was negative 1/5, so that's one of our answers. And then we have ar, so then we have negative 1/5 times 2. So that's negative 1/5 times 2 over 1 gives us negative 2/5. And so those are our answers. Our numbers are negative 1/10, negative 1/5, and negative 2/5. So that's the end of the recording. Now you need to call, text, or Skype message me so we can discuss this recording and you can get credit for this assignment. Have a great day.